we start talking about the workflow of creating an app in iOS or working with Xcode, I'd like to talk a little bit about the software development lifecycle. This is sort of the workflow of developing any application or app. I'm going to contextualize this a little bit for iOS, but the steps I'm going to discuss, these 5 different steps, pretty much apply to whether you're developing something for Android, iOS, Windows, Linux, Xbox, whatever. This is how we develop software as well as things in the cloud or even websites. So the first step in this software development lifecycle is a needs assessment. And that is that we believe that there is a reason to develop this application, that we can develop an app or an application that will meet a particular need, solve a problem, provide entertainment in the case of a game. So we have some idea. And what would happen here in this phase is we would brainstorm the features. Now, my experience is this works best if you have a lot of people to brainstorm or a group of people because somebody else will come up with an idea that you hadn't thought of or will spur another idea that based on what somebody else said. So brainstorming is really kind of a great idea, working with a client as well, going, okay, what is this project going to look like and what does it need to do? What are the features that we need? Developers often use something called a wireframe, or I'm going to refer to it a little more old school as storyboard, and that can be confusing, and we're going to talk about storyboards in a different context here in a minute. This is the basically sketching out with paper and pencil what the interface is going to look like. This is interface design. So we're going to create the user interface as well as the user experience will be part of this. And those two are separate things. How is the user going to use our product efficiently and effectively? When it comes to coding, and we need to take some input and generate some output, what's the process we would go through to get that? What are the steps? And that would be our algorithm design. Those steps may be written out just as English-like syntax. We call that pseudocode. Or we can do it with a graphical nature of a flowchart. We also need to think about is if this application is going to have some back-end data, what does that data look like? We need to design that data. What information do we need to collect from the user, from people, from the cloud? Those are all part of the needs assessment. That then, once that's put together, we then go into the interface design. And in interface design, we're going to develop the interface using one of 2 ways. We can use a storyboard. Now, this is the second context of that term storyboard. And you can see where Apple came up with the term storyboard because it really is taking sort of that sketch and making the interface active. You'll see a little IB there. That's the interface builder. That's sort of the framework that we use in working with storyboards. There's a newer methodology called Swift UI in which we can do this programmatically. It does include a visual element though, so as we create our code to design the interface, we can see what it's going to look like. We would also gather resources in this stage. Those resources might be the media that we need. It could be I need some graphics, maybe for a background, or I need images that I want to display as part of my interface. Might be audio. It could be video. So there's various media, multimedia resources we might want, but then also that data. We need to gather that data. That might be a text file that we're simply going to pull information from. It could be a back-end data file residing in the cloud somewhere. But we need to know what that is. Once we have that information, we've designed our interface, the next phase or step is step 3, and that is to code it. And here, we're going to code with iOS in a language called Swift. There might be some other options. We can add some stuff in. Sometimes we can use other languages as well as Swift. Objective-C is an older language that still comes into play for probably more traditional app developers. But we might need to code something maybe on the cloud through PHP or JavaScript or something that Swift is going to connect to. As we're coding and we design our interface and we think we've got this where we want it to go, we then have to test. And this is a very critical process. We want to make sure our program works before we ever distribute it to anybody. So we talk about taking our code and our interface, and we're going to go through a build process, which is the compilation of that into code that can run on our mobile device, whether it be an iPhone or an iPad. We can test that in the simulator, or sometimes referred to as an emulator, and within Xcode, our environment, we can basically run a simulator of any type of iOS device, whether it be an iPhone 8, an iPhone 11, an iPhone 12 Pro, or an iPad, or even an iPod. We can choose the device, and we can also choose the operating system on that device, what version of the operating system. We can do device testing on our own devices as well. We can deploy our beta product to our device and test it on our physical devices. We can do unit tests. We're only testing part of it, and we're designing some tests to make sure a particular aspect of the program works. And I put up here also kind of between the test and the deployment, because we probably want to go through our simulator testing and device testing. When we think we've got this working, we might want to have a bunch of people beta test it for us. And there's a product called TestFlight in which we can distribute our product not through the Apple Store, but through TestFlight, and invite people to test it and use it on their devices and provide feedback. Now, more often than not, as we're testing, we're going to have some problems. Things aren't going to work the way we expect it to work. And so we're going to do a process called debugging. We have to go back to our code and make some modifications in our code. And that is something every programmer does, regardless of if they're a newbie or if they've been developing software for 50 years. We all go through this debugging and making changes process. It's very rare that I would create an app, at least an app of any complexity, and have it work exactly like I want it to the very first time without having to make some changes. Sometimes those changes might be that I need to change the interface. I thought of a better way to make this interface more usable for the user. Or it might be I thought of another feature to add in. Sometimes we go back to the needs assessment as we want to add in features, and that might change our interface, it might change our code, and so forth. Word of caution there, what you really want to do in that needs assessment is be very thorough. You want to try to avoid scope creep. And scope creep is where your project is constantly changing, and we're adding more stuff in. And if you're working with a client, you need to make it very clear there's additional charges as they want to make changes to this thing, because it's going to be an added time to you and to your development team. So it's a kind of a cyclical process from testing back to coding, and sometimes back to interface design, and sometimes back to the needs assessment. But once you get this product working and you're ready to say, okay, I'm ready to give this out to users and have them pay me for it, have them just use it, whatever, that becomes the deployment stage. And in the deployment stage, we're going to prepare our product. We're going to bundle it to be distributed through the App Store or through an enterprise distribution. Maybe you don't want this to be available to the world. You only want it to be available to your company. That would be an enterprise distribution. There's a new product called StoreKit that allows you to test your product in a lot of the same ways that the Apple folks would do in the App Store to make sure it's really ready to go into the App Store. Getting stuff in the App Store is not an easy process. There's a lot of hoops to jump through, and you have to provide a website of support and things like that, or other considerations that are part of getting something in the App Store. I want to point out the tool we're working with is Xcode, and other than the needs assessment, really everything else is taking place within the Xcode environment. We're designing our interface in Xcode. We're coding it in Xcode. We're testing it through Xcode. We're even bundling it and preparing it and setting out for deployment in Xcode. The Xcode is what we call an IDE. It's the Integrated Development Environment. All these phases of development take place in that one environment. That's an IDE. Okay, so with that in mind, let's talk about the workflow of developing a product within Xcode and walk you through a simple project there. Let's talk a little bit about the needs assessment and what happens there. This is also referred to as the planning stage. So we're going to plan out our project that we want to create, and our need is going to be that given the diameter of a circle, I want to calculate what the area and circumference of that circle is. Now in your CS 105 and your previous programming courses, you've talked about input, process, and output. So everything we design, usually in software development, follows the hardware of input, usually getting input from the keyboard, mouse, things like that, the output being the display or a printer, and then the process being the processor. In software development, it's also input, process, and output. And then, of course, there's also the element of storage as well. So our input here, what we need to know or get from the user is the diameter of the circle. What we want to display is the area and the circumference of that circle. And we know that a circle, circumference, we have a formula to calculate that as the diameter times pi, or 2 pi r, and the area is pi r squared. So our process then to get from the input to the output is what we call our algorithm. What are the steps to get from input to output? What are the steps to complete a process? So in pseudocode, which is just a simple English syntax, we can write out the steps. We need to get the diameter from the user. We're going to assign that to a variable called d. We're going to calculate the radius, which is half the diameter, and assign that to a variable called r. We're going to calculate the circumference as being pi times diameter, or pi times 2r, and calculate the area as pi times r squared. And then we want to display the circumference and the areas. So we're going to display the variables, the values of the variables circum and area. We can also display that as a flowchart, just a graphical representation of that. I'm probably a little more old school, and I think visually I like to use flowcharts. And we have different symbols for flowcharts, and you've learned these through your previous programming course, hopefully. But we'd have a start symbol, kind of an oval, and then arrows going from the different flowchart symbols. So the next one would be a parallelogram, which would be getting the diameter. It's going to represent input. Our process is always a rectangle, and our process, once we get the input and assign it to D, we can calculate the radius, the circumference, and the area using those formulas. And then we have a parallelogram again for output. In this case, we're displaying the circumference and the area. And then finally, that's our end of our flow, end of our algorithm. We have another oval for ending. And of course, we have other shapes such as diamonds for making decisions. But that's the process we would go through in deciding how is this thing going to work. Once we have that information, then we're ready to develop. But the more time you spend in planning and thinking through all the features and how this is going to work, the easier your development will be. Now, I mentioned storyboarding. In the context of UI storyboarding or sketching out our user interface, you can do this with paper and pencil. You can do it with products like Sketch or Adobe XD, Illustrator, Photoshop, all kinds of tools you can use. So I a lot of times just use paper and pencil. And I'll sketch out the window. So the larger rectangle here is the screen itself. I want some labels at the top. They're going to have the title and my name as the developer. Then I'm going to have a label that says enter diameter, and then a text field, which would be I'm going to name txt diameter. Now, I like to use Hungarian notation, which really comes from the Microsoft side of C# and VB, more so VB than C#, but it's the way I've always programmed. And so I use txt for the beginning of a text box, and LBL for the beginning of a label, and BTN as the beginning 3 letters of a button. And so as I look at my code, based on the names of my objects, I know right away what type of object they are. So then I have a button that's going to say calculate on it. We're going to name that BTN calculate. I'm going to have another label for my output. We'll call it LBL output. That could be a text field as well. It could be txt output. And then we'll display an image of a circle. And so that's going to be one of the resources I'm going to need in terms of putting images into my project. While we're talking about gathering resources, let me mention a few things about images and icons. And we'll talk a lot more about this down the road. But technically, every image you put into Xcode should have 3 versions at 3 different resolutions, because we have different devices with different resolutions. And an image for an iPhone 6 will look very poor on an iPad 10.5-inch screen because those resolutions are very different. So Apple, one of the things you'll be required in putting in a product into the Apple Store is every image must have 3 different resolutions. And they're always named the same, but with an at 3x, an at 2x, and an at 1x. So the little circle diagram that I showed you earlier, I created in Photoshop. And I always create the larger one first because you always want to go from large to small. If you go from small to large, it'll rasterize and look horrible at the larger resolution. So I create the first one, and since I added the text below it in terms of the formulas for circumference and area, I created that as 1200 by 1400 pixels. And then I reduced it down to size by 67% or to 67% and made one that's 800 by 934. And then I reduced that in size by half to 400 by 467. Now, I'm going to introduce a little JavaScript that you can use within Photoshop to just create the large one, and with the push of a button, basically have it create the others and give them the names and put them all in a folder. So it'll save you some time. There are other tools out there for designing images and be able to resize them. I like to use Photoshop. It's kind of the industry standard in terms of graphic development and graphic design. We also teach Photoshop here at South Mountain, and we recommend all of our mobile app students should take a Photoshop class because everything is so visual these days. You need to know how to work with graphics. Now, a lot of times as a developer, you might have a graphic designer you're working with who will design these things for you. Same with your user interface. On large projects, a lot of times you might have a UI or UX specialist who helps design what those screens should look like for maximum use and efficiency and effectiveness. Sometimes, especially as a freelance developer, you get to play all three roles. You're the UI UX designer, you're the graphic designer, and you're also the programmer or the person coding all this. So we have three different resolutions for every image. And those go into a folder called XC assets or Xcode assets. It might look more like X cassettes. And we'll show you how to do that. Now, if that's not bad enough, let's talk about icons. You are required to have an icon for your project to put it into the Apple Store. And there's lots of rules for icons. Apple expects icons to be fairly simple. Usually no text or very limited text. So this was the icon I developed for my circle calculator, kind of a circle background with the buttons that you might find on a calculator. Now here's the trick. There are not only 3 versions of graphics for your icons, there's actually 13 different versions. And so the largest one is 1024 by 1024 pixels. That's where I start. And then I resize my images down to these other resolutions of 180 by 180, 167 by 167, and so forth, all the way down to 20 by 20 pixels. Now, 20 by 20 pixels, you don't have a lot of real estate to work with. So that's why you need to keep your icons very simple. The reality is the 20 by 20 pixels probably is going to be on an older phone that most people aren't running, but you are required to have that to put it into the App Store. The Human Interface Guideline, or what we call the HIG, this Human Interface Guide, put out by Apple, will specify all these things that you'll need to successfully get your app accepted into the Apple Store. All right, with that, let's jump into Xcode. If you just jumped into this video, you can see all the videos from the iOS App Development Cohort playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos that I create, you can click my picture up in the top right and subscribe to the channel.